Currently, Yellowstone National Park contains more than 10,000 hydrothermal features to date. If we didn't know any better, we could say Earth has hit its geothermic jackpot. We're talking scorching waters, steaming vents, and a whole lot of geysers. And do you know what's behind this mind-blowing phenomenon? It's all thanks to a simmering supervolcano that lies just beneath the surface. However, what still remains a mystery is why this jackpot has not been tapped into yet. Is there something we are missing out on? Keep watching to find out the answer to this question and some mind-bending facts about Yellowstone National Park. Yellowstone sits atop a beautiful plateau up in the Rocky Mountains in the United States, and as you can imagine, it gets pretty chilly up there. With over 6 months of snowbound goodness each year, you'd better bundle up if you're planning to visit. The mean annual temperature hovers around an almost freezing 2.2 degrees Celsius. However, there is a surprising twist here. Yellowstone is not just your average snowy wonderland. As we mentioned, it's also an active geothermal hotspot. There are hot springs gushing out water at around 92 degrees Celsius. For perspective, that's the boiling point of water at Yellowstone's average altitude. Plus, there are steam vents reaching scorching temperatures of up to 135 degrees Celsius. However, only about 0.3% of Yellowstone's vast terrain is thermal ground. So most places in the park are not any hotter than your average spot in the Rockies. But here's where things get really interesting. In certain thermal areas of Yellowstone, the heat flow is off the charts. We're talking over 100 watts per square meter. To put that into perspective, it's about 50 times more heat flow than Yellowstone's average and about 2,000 times more than the typical North American terrain. So where does all this intense heat come from? Well, it's rooted in molten rock, which is also known as magma. It lurks beneath the caldera of Yellowstone. This magma is generated by what we call the Yellowstone hotspot, which is a partially molten region of the Earth's mantle. And get this, it is situated hundreds of kilometers below the Earth's surface. Can you imagine the heat that it generates? Well, that heat is what fuels all those incredible features that make Yellowstone so unique. Vents, geysers, hot springs, and those bubbling mud pots. Now, let's talk about the pressure this mighty magma chamber exerts on the crust above. It's so significant that it has actually lifted Yellowstone and around 300 miles of the surrounding area 1,700 feet higher than they would be otherwise. Mother Nature decided to give these lands a little boost, whether they asked for it or not. What we don't realize is that Mother Nature also gave us a geothermal energy jackpot, a source of renewable energy that can solve the world's power issues in a mere second. Let's get into geothermal energy 101. Geothermal energy is the hidden gem of power sources that doesn't get enough recognition. Sure, not every country can tap into this amazing resource because, well, let's face it, not every country is lucky enough to be sitting on top of a magma chamber ready to provide some thermal juice. But for the countries that do have access to it, they know how to make the most of it. Now, in Yellowstone, there are two main processes at play which produce heat: conduction and convection. Conduction is like a game of hot potato, where heat gets passed from a hotter material to a colder material. You've probably experienced this when you've touched a hot stove and felt the heat travel through the pot to your hand. Well, in Yellowstone, conduction helps transfer heat from the depths of the earth to the more shallow areas. About 25% of the heat released from the ground in Yellowstone is due to conduction. So what about convection? In convection, heat is transported by hot magma in motion. In Yellowstone's case, convection comes into play big time. Convection of molten rock helps carry heat up through the massive Yellowstone caldera. As we move closer to the surface, convection of hot groundwater takes the spotlight. It drives the show for geysers, hot springs, and fumaroles, which are openings in or around a volcano where hot gases pass through. In fact, convection accounts for roughly 75% of the heat released from the ground in Yellowstone. However, the real question remains, why can't the US simply build a geothermal plant in Yellowstone? Before we get to that question, first let us look at the bigger picture. First off, how much geothermal energy is enough? Alright, let's delve into the hypothetical world where we've got our renewable energy game on point. In this world, we have invested heavily in wind, solar, hydroelectric, and nuclear power to the extent that these sources make up 50% of the electricity generated worldwide. Now, the big question is, can we rely on volcanic heat to cover the remaining 50%? Let's crunch some numbers. According to the CIA World Factbook, back in 2014, the world's electricity consumption was around 23.16 kilowatt hours. Now, let's break that down a bit. A watt is a measure of power, and it's measured in units of energy called joules per second. A kilowatt is simply 1,000 watts, or 1,000 joules per second. So a kilowatt hour is what you get when you consume 1,000 watts for an hour straight, assuming the electricity usage remains constant. It's like saying you've eaten 1,000 apples from a tree falling to the ground. Easier to visualize, right? So in 2014, the world consumed a staggering 77 quintillion joules, where a quintillion equals 10 raised to the power of 18. For reference, a billion equals 10 raised to the power of 9. Now, that might sound like an astronomical amount, but nature has a way of showing us that it's even more powerful than we often give it credit for. Take hurricanes, for example. Your average hurricane releases around 600 trillion joules of energy per second. Wrap your head around this. In just one day, a hurricane produces 52 quintillion joules of energy. That's almost enough to power the entire planet. Sadly, harnessing hurricane energy is a technical impossibility, so we'll have to turn to volcanoes instead. The exact amount of geothermal energy required to power half the planet is difficult to pinpoint. It depends on various factors like the efficiency of the geothermal power plants and the geothermal resources available. However, we do know that geothermal energy can be a substantial contributor. Geothermal power plants typically generate electricity in the megawatt range. So, if we combine multiple geothermal power plants around the world, each producing several megawatts of electricity, we might just have a shot at fulfilling that remaining 50%. Is the US willing to take that shot? While Yellowstone itself is a treasure trove of geothermal resources, it's actually off limits to any sort of development. You see, when it comes to geothermal projects, they often interfere with the natural flow of nearby hot springs and other geothermal features like geysers. And understandably, the US doesn't want to mess with the magic of Yellowstone's natural beauty, and since it has been named as a national park, it is likely Yellowstone will not be an option in the future either. However, getting permission to develop geothermal energy in the region outside the park is quite questionable. The United States does have other natural heat sources that are being put to good use for geothermal energy. One shining example is good old California. At locations like the geysers, Salton Sea, Coso, Casa Diablo, and various other geothermal systems, they're generating around 4 to 5 gigawatts of electricity. This amount of geothermal power is enough to provide energy for several million people. There is a dilemma in developing geothermal power in pristine areas like national parks. Even if a geothermal power plant could coexist without destroying the iconic features of a region, it would still be quite the eyesore in such a pristine setting. Peter Lawson, a geologist at Washington State University, sums it up pretty well by saying that national parks are sacred. And surprisingly, many folks within the geothermal community tend to agree. They see these special places as symbols of what our Earth has to offer in terms of stored thermal energy, but they don't necessarily believe that they should be exploited for power generation. Think about it this way. It would be transforming a region known for its breathtaking natural beauty and diverse wildlife into an industrialized concrete jungle with power lines crisscrossing the landscape. Sound familiar? For a much clearer picture of the harm of creating a power plant, New Zealand serves as a lesson. Back in the 1950s, when New Zealand decided to build a geothermal power plant near Wairākei Basin, things took a bit of a sad turn. Unfortunately, the construction of the plant ended up destroying 70 geysers and 240 hot springs in the area. So, sometimes the decision not to use geothermal power in these areas is more about the social and environmental impact rather than a technological limitation. While we continue to experience an increasing number of technological advances in all areas of life, hopefully we are able to continue to appreciate Earth's natural beauty and realize there's a delicate balance between progress for humankind and preserving the few precious natural spaces we have left.